Most of you find that it is very hard to deal with the question about locus. So how about today we have a very quick review of all the locuses or most of the locuses you should know for your DSC. Number one, so it should be the easiest one, which is called equidistance from a point. So it is talking about a point, equidistance, so that's why you have a circle. So this one, it goes to a circle. So for example, if you have a point called 3, 4, and you have a equidistance called 7, and then so it generates a circle which is in the formula called x minus 3 square, y minus 4 square, equal to 7 square, which is a 49. So coming up next, you have point number 2. So how about we call equidistance from 2 points? Equidistance. Okay, let's wait. Equidistant from 2 points. So it may be a picture requires your imagination. And as you have point A, you have, let's wait, you have point A, you have also point B. So because they are equidistant from 2 points, so that's why a midpoint should be considered. So I use a yellow. So midpoint M should be considered. So in order to sketch for the locus, then so the locus will be a line which is passing through this midpoint M, and which is equidistant from A and B. So you may consider the idea of isosceles triangle. So to any point along the red line, so you can see isosceles triangle, any point isosceles triangle, any point on red line, isosceles triangle, etc. So to this line, we have to remember 2 things. Number one, so we describe this one as perpendicular bisector. Perpendicular bisector. So can you see that so M is the midpoint of AB, as well as so it makes a right angle to the line AB. So that's why we call it perpendicular bisector. Point number 2 is how to find the equation, the red line, for example, we call it gamma. So there are generally 2 ways we can do. So first way is called follow straight. If you remember in my lesson, follow straight means we will let the let P be xy, which is a random point on this locus, and then next you have we see according to the question, because of equidistance, so we have PA is equal to PB. So as a result, then you spell the distance formula, and then you have x minus something square, y minus something square. For example, if we know that A is 0.12, B is 0.34, so that's why it's x minus 1 square, y minus 2 square for the distance of PA. Similarly, we also have x minus 3 square, y minus 4 square for the distance of PB. So then we generate the equation of the locus. So afterward, you need to take away the square roots because we have both on both sides. And then so you have x minus 1 square, y minus 2 square equal to x minus 3 square, y minus 4 square. And then you continue to simplify it. And then so this is the first way. Now then we have the second way, which is a smarter way. As you know, this is a very well-known question in the public exam. Because we know that it is a perpendicular bisector, whereas the point M is a midpoint. So that's why we let M be the midpoint of the line AB. So as a result, point M can be using the midpoint formula. So you have 1 plus 3 over 2, 2 plus 4 over 2, so which gives you 2 and 3 for the midpoints. And then you can also find the slope of AB, so which is equal to 4 minus 2, 3 minus 1, so that means it's 2 over 2, which is 1. So that's why the slope of gamma, because of perpendicular, so you know it's minus 1 over 1, so it's minus 1. So as a result, the equation of gamma can be found in an easier way, because we have known that you have a point 2, 3 on the line, you have the slope as well. So that's why it's y minus 3 equal to minus of x minus 2. And then so you continue to simplify the question. After having equidistant from 1 point and 2 point, so now we start talking about equidistant from line. So then number 3, equidistant equidistant from a line. So that means at first you have a line L, and then so you have to find the locus of it. So because there's a straight line, so you may be either walking on its left hand side, or you may be walking along the right hand side. So this is called equidistant from a line L. So you have two locus, so a pair of straight lines called gamma, which I draw in yellow. So in order to describe it, you will see that so they are a pair of straight lines. So the most important thing is, so they are parallel to the line L. So this is part 3. Next, we have number 4. So we can also have equidistance from two lines. But to this, we have two cases to consider. So one is you can talk about two parallel lines, while the second case is two intersecting lines. So in both cases, it gives you different locuses. Okay, in case 1, you have first of all two parallel lines. For example, I call L1 and L2. So you imagine that you are walking between them, so that you make an equidistant between the lines. So that's why the locus will be the line yellow, which is equidistant from L1, L2. So I call it gamma. And then so you see that it is a straight line, so which is parallel to both L1 and L2. So say this is the first case. Coming to the second case, you have two intersecting lines. That means simply it's a big cross. And then in order to find the equation of or the locus, then it comes up with first one. So you may have this yellow one, which makes the equidistant from L1 and L2. So you also have another one which is equidistant from L1 and L2 as well. And then we need to find some ways to describe the feature about these lines. Can you see that this yellow line, so it is a line of symmetry of L1 and L2. So which means these two angles are the same and these two angles are the same. Similarly, for this red line, another locus, so it is also the line of symmetry of L1 and L2. So that means it cuts the angle into equal half. Towards this, then we can describe these locuses or the two lines as follow. Then you can say they are the two angle bisectors of L1 and L2. Next, we can see when it comes to the fifth case, so which is called equidistance from a point, distance from a point, and also a line. A point and a line. So for calculation, you have to read the notes for more details, and now I'll just give you some ideas. So you have point line L, which is vertical. You have another point which is called C, and the locus will be, okay, first of all, mark the midpoint between the line L and C first. Then next, according to this point, so then you draw a parabola like eating the point C. Then it is the locus called gamma in this picture. So similar case will be you have a horizontal line L, you have a point C, And then next, first of all, you mark the midpoint between C and L. And next, you draw a parabola eating point C. And so for the calculation, make sure that you go back to the notes for more details. There are some other variations of locus or other question of locus you may see in different papers. So in one case will be we can call, so P is a moving point such that PA perpendicular to PB. So where A, for example, I give it is 1, 2, B is called 3, 4, and now you have to find the locus. So which is called gamma. So as a picture, you have point 1, 2. So you have point B, which is called 3, 4. And now you have a point P, so which is perpendicular. So perpendicular to, not perpendicular. So P, it makes two lines, P, so that PA is perpendicular to PB. So locus is better for you to remember it because at last it goes to a circle. So which is passing through point A and point B. As well as if you precisely look at the picture, AB is also the diameter. So this is the case of how you can do the question. So if you want use the idea of follow straight to find the equation of the locus gamma, so we can let, so here comes the answer. So we can let P be xy. So after that, you can write down the formula precisely. Slope of PA, which is y minus 2, x minus 1, multiply to slope of PB, which is called y minus 4, x minus 3, and then the slope is minus 1. And finally, you will obtain the equation of the circle. Another very similar question would be, so please compare it carefully with number 6. So we also call P is a moving point such that PA, but this time is perpendicular to AB. So again, we suppose A is 1, 2, B is called point 3, 4, and you have to find the locus, so called gamma. Okay, so now you have point A, 1, 2, you have point B called 3, 4, and then next P is a point moving, so that, for example, this is one piece of the locus, so that PA is perpendicular to AB, making a right angle. Can you imagine what is the locus? This time, instead of a circle, so you will see it's only a straight line passing through point A. So in order to avoid mistakes or ambiguity between 6 and 7, I still suggest you to use the idea of follow straight, and then follow straight the information. If it tells you about perpendicular, then use slope multiply to be minus 1. So it will be a very safe way to deal with a question about locus. So in this question, then you will see that in order to find the locus in this question, let's wait. So then we also let P be xy, so which is a very standard start of finding locus. So as a result, according to the question, you have y minus 2 over x minus 1, which stands for the slope of the line PA, and then we multiply to AB. So it's 4 minus 2, 3 minus 1, and which makes 90 degree. That means the slope, the product of slope is minus 1. So that's why you can go ahead to simplify the expression and obtain an equation of straight line. So here's the end of the quick review about locus. Generally speaking, you will see that locus, there are only some variations. For example, you will see number 1, so the outcome may be a straight line, so like equidistant from a straight line or equidistant from two straight lines. The second possibility of a locus, it may be circle. So here we demonstrate two ideas. Number 1 is equidistant from a point, and the other one is talking about perpendicular. And the hardest job will be about parabola. So which is only happen in the case when you have equidistant from a point and also a straight line. So finally, you have to also note that the format of the formula of the locus is as follow. Straight line, so the formula is y is mx plus c, while for circle is x minus h square, y minus k square, whereas hk they stand for center equal to radius square. Well, for parabola, of course we know is about a squared plus bx plus c. But in the sense of locus, and then normally we will have another possibilities. For example, like x is something about y. So you don't have to about y squared. So you have to note the difference.